In the previous tutorial, I demonstrated the computing of time frequency representation of waveform data. You see, once finished, the terabyte ratio trial has been analyzed with CWT sequence model standard method. That means it has done. Now we just exit it. And we come here, we can see the single trial. As you can see, this is the time frequency data. This is accumulated spectrogram. Here you can see the accumulated not enough data to fill all of them because the selected time window may be shorter than two of the spectrogram. In the spectrum here, we show the either electrodes. For example, we can see each electrodes. Here means either power or real data or imaginary data to show the spectral power. And this is the scale bar, the color bar. That's how it encodes the spectral power. This is a frequency. That means from 70 to 2000. That's what we selected. This is the time window. Because we used sequential or accumulated spectral power, so this time window is much shorter than the original time window. That's why we come here. Once we select here, you can see that we tell you the frequency, the power. You see in this time window, the summation, because if we see this here, you see it will give you the average power of this selection. And here we see the EEG electrodes, so we can go through all the electrodes. See, they will change. And here we can see the spectral power. That's typically we need. We also consider real data, the imaginary data. Those data, because it has polarity, so we can use the real imaginary power to compute the sources. The power data phase, as you can see, is always red. Color, that means it don't have any polarity information. So that's why we compute real and imaginary. You may wonder if we can compute all those channels. Yes, here we have a group. As you can see, each electrode we have a group. That means all the sensors. This is group mean. That's the combination of all channels. Or we call the global power, global mean. This group minimal, that's minimum should be there. Maximum, group maximum. The average positive, average negative, and the root mean square. Of course, the negative is almost zero, but if we use real data, it should have something. This will allow us to define the show of the data. For example, you can increase the power, adjust it. You can remove the polarity. Depends what you need. Say the spectrum, they will change. So you know where is the power, the peak of the spectrum. You click this one, that means measure them. If you click this one, it will move left or right, up and down. Of course, you can zoom in, zoom out. you can outfit. The program automatically calculates the fit. You can refresh them, you can reset them. Basically, reset this is 0. And you can uncheck the selection. So the 6th line, you say select line is gone. Don't have selection. Only when you click this one, you get the selection line. You can select the range, measure the power. You can, of course, you can move the spectral. Use this one. Or you can click the information here, so that will show you which channel, the maximum, minimum, and this means the range. At the bottom, you can uncheck this one to remove the scale bar. This one, the color bar, encoding the spectral power. You can uncheck the measure. Basically, this is gone. You don't measure it anymore. Of course, you can't show the waveform. You can link it to the counter map. You can even move them. But this is basically for us to view the spectral power or real or imaging data of the time frequency representation.